For 30 days, I stopped trusting my instincts and started trusting algorithms, not motivational quotes, not gut feelings, not even doctor's intuition. Every decision about my body, what I ate, how I trained, how I slept, what risks I carried, was guided by AI-driven health systems analyzing my data in ways no human ever could. Here's the unsettling part. Within the first week, the algorithms flagged risks I felt nothing about. No symptoms, no warning signs, just probability curves, anomaly detection, and pattern recognition quietly whispering, something here doesn't look right. That's the paradox we're living in right now. We've been taught that health is about how you feel. AI healthcare is proving it's about what you can't feel. Yet, artificial intelligence in medicine is already outperforming humans in detecting early-stage cancers, identifying silent heart disease, and spotting metabolic dysfunction years before diagnosis. Not hypothetically, not someday, right now. And yet, most of us are still navigating our health like it's 1999. Annual checkups, generic ranges, reactive treatment, while AI systems are reading billions of biological data points beneath the surface. So I decided to test the future personally. For 30 days, I became an AI engineer human, using predictive diagnostics, personalized biometrics, genomics, and machine intelligence to optimize decisions usually left to chance. But this experiment wasn't about biohacking bravado. It raised a far more uncomfortable question. If an algorithm can detect disease earlier than you can feel it, who should you trust with your body? And even deeper than that, what happens to human agency, privacy, and identity when your biology becomes a dataset, and your future health becomes a probability score? Because what I discovered wasn't just about optimization. It was about a fundamental shift in how humans will understand risk, responsibility, and longevity in the age of AI-powered medicine. And the most surprising insight came before the technology impressed me. It came when I realized what we've been blind to all along. This experiment couldn't have happened 5 years ago. Not because the ambition didn't exist, but because the infrastructure didn't. Right now, we're standing at a convergence point. AI healthcare models trained on millions of patients, FDA-approved CRISPR therapies, predictive diagnostics running silently in hospitals, and consumer-grade biometrics generating clinical-grade insight. This isn't futurism anymore. It's deployment. Here's the uncomfortable truth most people haven't internalized yet. The biggest health risks of the next decade won't come from rare diseases. They'll come from late detection. Half of heart attacks show no prior symptoms. Most pancreatic cancers are discovered at stage 4. Type 2 diabetes quietly progresses for years before diagnosis. By the time the body speaks, the window for prevention is often gone. Traditional medicine is reactive by design. AI-driven medicine is predictive by nature. And that difference changes everything. Hospitals are already using AI diagnostics to reduce error rates by nearly half in some internal medicine cases. Imaging systems powered by machine learning are matching, and in specific tasks succeeding, human specialists. Algorithms don't get tired. They don't anchor to first impressions. They don't miss weak signals buried inside massive datasets. But here's the real stake, and this is where it becomes personal. For the first time in history, early detection is no longer limited by human attention. It's limited by whether you choose to look. The tools now exist to surface risks years earlier than symptoms. The question is whether society and individuals are ready to live with that knowledge. Because once an algorithm tells you there's a statistically significant risk here, you can't unknow it. And that introduces a new psychological burden. Are you empowered by foresight or trapped by probability? This is why the 30-day experiment mattered. Not to chase perfection, but to understand what it feels like to live inside a future where your health is continuously interpreted, scored, and forecasted, whether you're ready or not. And the first system I tested revealed just how different machine intelligence actually sees a human body, not as organs, not as symptoms, but as patterns. To understand how I was able to hand my biology to machines for 30 days, you have to rewind. Not a Silicon Valley hype, but to a quieter revolution that started in hospitals, research labs, and server rooms years ago. AI in healthcare didn't begin as an optimization tool. It began as a crisis response. Medicine was drowning in data. Radiology images, pathology slides, genomic sequences, continuous vitals, lab markers. Far more information than any human clinician could fully process. Diagnostic error rates hovered stubbornly high, not because doctors lacked intelligence, but because human cognition has limits. That's where machine learning entered. Early models weren't built to replace doctors. They were built to answer a narrower question. Can a system trained on millions of prior cases recognize patterns humans miss? The answer, quietly and repeatedly, was yes. Neural networks began identifying subtle pixel-level changes in mammograms that correlate with early malignancy. Algorithms trained on skin lesion databases learned to distinguish benign from malignant patterns with near-dermatologist-level accuracy. In pathology, AI systems started flagging microscopic cancer signals invisible to the naked eye. But something unexpected happened. These models didn't just replicate human expertise. They generalized it. They learned from populations instead of experience, from distributions instead of anecdotes. And then genomics changed everything. Once DNA sequencing costs collapsed, biology became computable. Suddenly, AI wasn't just reading images. It was reading you. Millions of genetic variants, metabolic signals, and longitudinal biomarkers could be analyzed simultaneously. That's when healthcare crossed a threshold. Medicine stopped being episodic and became probabilistic. Health stopped being reactive and became predictive. The systems guiding my 30-day experiment are descendants of that shift, trained on peer-reviewed datasets, validated in clinical trials, and in many cases, already cleared for real-world use. The systems guiding my 30-day experiment are descendants of that shift, trained on peer-reviewed datasets, validated in clinical trials, and in many cases, already cleared for real-world use. But understanding where this power came from raises a more unsettling realization. These systems weren't designed for individuals. They were designed for populations. So what happens when population intelligence is pointed directly at a single human life? That's where the experiment truly began. Handing your biology to AI sounds dramatic, almost mystical. But under the hood, nothing magical is happening. What is happening is something far more unsettling and more powerful. For 30 days, my body became a continuous data stream. Blood markers, imaging data, heart rhythm variability, glucose fluctuations, genetic variants, sleep cycles, inflammation signals, each one meaningless alone, transformational together. This is where biodata intelligence comes in. Modern AI healthcare systems don't make decisions the way humans do. They don't rely on intuition or experience. They operate on probability landscapes, mapping your biology against millions of comparable biological trajectories. Take diagnostics. AI models trained on hundreds of thousands of mammograms don't look for cancer the way a radiologist does. They detect statistical deviations, pixel-level patterns correlated with future malignancy, even when no visible tumor exists yet. The same logic applies to melanoma detection, pathology slides, and MRI analysis. Now layer genomics on top. Your DNA doesn't predict destiny. It shifts probabilities. AI systems analyze how specific variants influence drug metabolism, inflammation response, insulin sensitivity, or neurological signaling. Not certainties. Likelihoods. Add real-time biometrics. A continuous glucose monitor doesn't tell you what sugar is. It tells you how your metabolism reacts under different conditions. HRV data doesn't measure fitness. It measures nervous system strain, recovery debt, and resilience. AI fuses all of this, not to give answers, but to surface risk gradients. This is precision medicine in its raw form. No diagnoses, no absolutes, just shifting probabilities updated daily. And here's the critical nuance most videos ignore. These systems are extraordinarily good at pattern recognition, but they don't understand causality. They can say what tends to happen next, not why it will, which means the power of AI health optimization doesn't lie in blind obedience. It lies in interpretation. And that raises an uncomfortable question. If an algorithm sees disease risk rising before you feel anything at all, do you act early or wait until your body proves it's real. That decision defined the next phase of my experiment. Here's the part no dashboard prepares you for. The moment AI stops analyzing patients and starts analyzing you, the experience shifts from futuristic to deeply human. By week 1, patterns began surfacing that felt uncomfortably specific. Not dramatic diagnoses, not red alerts, subtle deviations. My glucose response to foods I'd always considered healthy spiked higher than expected. Sleep debt showed up in my HRV days before I felt tired. Inflammatory markers nudged upward after travel, long before any symptoms appeared. None of this would have triggered a doctor's visit. But AI doesn't wait for symptoms. It watches trajectories. One of the strangest realizations was how often my intuition was wrong. I felt recovered when my nervous system wasn't. I felt productive while physiological stress quietly accumulated. I felt fine while biomarkers drifted in the wrong direction. And then came the psychological shift. When you see your biology quantified daily, you stop negotiating with yourself. There's no arguing with trends, no rationalizing bad sleep, no pretending stress doesn't count because it's mental. It all counts. But here's what surprised me most. The AI didn't make decisions for me. It reframed them. Instead of asking, how do I feel today? I started asking, what direction is my body moving? That single shift changed behavior more than motivation ever had. Sleep became non-negotiable. Food became an experiment. Training became responsive, not aggressive. Recovery became strategic instead of reactive. This wasn't optimization in the superhero sense. It was alignment. And that's important because the goal of AI-driven health isn't perfection. It's earlier awareness. Still, there's a line most people never talk about. When systems know your body this well, they don't just reveal health patterns. They reveal vulnerability. And that raises a harder question. If an algorithm can see your weaknesses before you do, who else gets to see them? That's where this experiment stopped being personal and started becoming ethical. This is where the future gets uncomfortable, because the same AI systems that can detect disease early can also expose parts of you that were never meant to be shared. Genetic data isn't like a password. You can't reset it. And once it exists outside your body, control becomes complicated, fast. Most people assume health data is protected by HIPAA. But here's the reality. Most consumer genetic tests aren't covered by it. That means your DNA, your disease risks, drug responses, inherited traits, can live in databases governed by terms of service, not medical law. And even when companies promise privacy, the fine print matters. Some allow anonymized data to be used for research. Others share data with third parties. And anonymized genetic data, it's often not as anonymous as we think. Your genome is a fingerprint, and it implicates your relatives too. Then there's the issue no one wants to say out loud. While laws like GINA prevent certain types of genetic discrimination, they don't cover everything. Life insurance, long-term care, disability coverage. Those gaps matter. And ethically, there's another layer. When AI flags a potential disease years early, before symptoms, before certainty, what do you do with that knowledge? Lie differently? Worry constantly? Treat something that might never manifest? Early detection saves lives. But premature certainty can also steal peace. This is the paradox of predictive medicine. The more we know, the heavier the responsibility becomes. On individuals, on companies, on regulators. So the question isn't whether AI belongs in healthcare. It already does. The real question is who gets to decide how far it goes and who it ultimately serves. Because this technology can either empower individuals or quietly shift power away from them. And that tension doesn't resolve itself. Next, we need to zoom out beyond today's tools and ask where this trajectory is actually heading. Because the next phase isn't about monitoring health. It's about rewriting it. If the first wave of AI in healthcare was about seeing the body more clearly, the next wave is about changing it. Not hypothetically. Not someday. It's already happening. In late 2023, the FDA approved the first CRISPR-based therapies. treatments designed to permanently rewrite faulty genes. For patients with sickle cell disease, this didn't mean symptom management. It meant the near elimination of pain crises. For some, it meant a functional cure. That moment quietly redefined medicine. Because once you can edit genes, diagnosis is no longer the endpoint. It becomes a starting signal. Pair that with AI, systems that can identify disease risk years in advance, and medicine shifts from reactive to preemptive engineering. We're already seeing early signs. AI models are helping design drugs faster by identifying targets humans miss. Personalized oncology uses tumor genomics to tailor therapies down to individual mutations. CAR T-cell therapies train immune cells to hunt cancer with precision no drug can match. And then there's longevity science. Epigenetic clocks now estimate biological age more accurately than birthdays. AI tracks how sleep, nutrition, stress, and inflammation nudge that clock forward or backward, week by week. The implication is staggering. Health stops being a binary state, sick or well. It becomes a continuously adjustable system. But this future doesn't arrive evenly. Right now, these tools are expensive, experimental, unevenly distributed, and often optimized for those already privileged enough to access them, which means the next decade may widen the health gap before it narrows it. Those with early access won't just live longer. They'll detect, intervene, and adapt faster. That creates a new kind of inequality, not just in lifespan, but in biological optionality. And that forces a difficult reckoning. If technology can extend health span, who decides who gets it first? And what happens when health itself becomes a competitive advantage? Because the future of AI-driven medicine isn't just about curing disease. It's about redefining what it means to be human and who gets to become the upgraded version first. Every technological leap creates a moment where society has to pause and ask a dangerous question. Just because we can, should we? AI-driven genomics doesn't just analyze life. It intervenes in it. And that's where the ethical ground starts to crack. Take predictive medicine. If an AI can tell you, at age 25, that you have a 78% chance of developing Alzheimer's by 60, is that empowering or psychologically destabilizing? Does that data belong to you, your doctor, your insurance company, or the algorithm that inferred it? Now push further. What happens when AI doesn't just predict disease risk, but predicts behavioral tendencies, cognitive decline, or mental health vulnerability from your genome combined with biometric data? This is no longer just healthcare. It's identity forecasting. Then there's consent. Your genome doesn't just describe you. It partially describes your parents, your siblings, your future children. When one person uploads their DNA to an AI system, who else has implicitly been exposed? And once genetic data exists, it never expires. A data breach isn't like a stolen credit card. You can't cancel your DNA. There's also the specter of enhancement. CRISPR was built to fix broken genes, but the same tools could, in theory, optimize traits: muscle recovery, cognition, resistance to fatigue, even emotional regulation. At what point does treatment become enhancement? And who draws that line? Governments? Corporations? Algorithms trained on biased data? History gives us a warning. Every time biology and hierarchy mix, from eugenics to discriminatory medicine, the result has been harm masquerading as progress. AI doesn't remove that risk. It accelerates it, which is why the real battle ahead isn't just technical. It's moral, because the most powerful systems we're building won't fail due to lack of intelligence. They'll fail if we never decide what kind of future they're allowed to optimize for. And that raises the most uncomfortable question yet. If we don't define the ethics of AI-driven biology now, who will define them for us? After all the scans, the blood work, the wearables, the algorithms, the predictions, the dashboards, here's the uncomfortable truth. I didn't become superhuman. There was no overnight transformation, no cinematic montage where AI rewired my biology into perfection. What changed was something quieter and far more unsettling. For the first time, I stopped guessing. Instead of "I feel fine," I had data saying my inflammation markers were elevated. Instead of "this diet works for me," I could see glucose spikes that contradicted everything I believed. Instead of, I'm training hard, HRV showed my nervous system was close to burnout. AI didn't give me motivation. It removed denial. And that's when the real friction started. Because knowing isn't the same as changing. When an algorithm tells you that your sleep debt is sabotaging hormone balance, you still have to go to bed earlier. When your CGM shows a healthy food wrecks your glucose, you still have to stop eating it. When your biomarkers flag long-term risk, the responsibility doesn't shift the machine. It comes back to you. The most surprising change wasn't physical. It was psychological. I started making decisions differently, not emotionally, not habitually, but probabilistically. Every choice became a trade-off with visible consequences. And that's exhausting, because data removes comforting ambiguity. You can no longer hide behind maybe. The mirror is always on. By day 30, I realized something critical. AI didn't optimize my body. It exposed the cost of my lifestyle in advance. And once you see the future implications of your habits, you can't unsee them. That's when the experiment stopped feeling like empowerment and started feeling like accountability, which leads to the final question, the one no dashboard can answer. Is radical self-knowledge actually freedom, or is it just another form of pressure wrapped in the language of optimization? After 30 days inside this experiment, here's the cleanest conclusion I can give you. AI didn't make me healthier. It made my health unavoidable. And that distinction matters, because most of these tools don't fix problems. They surface them earlier than we're used to seeing. AI diagnostics catch patterns humans miss, but they don't replace doctors. Genetic tests reveal probabilities, not destinies. Wearables detect stress before you feel it, but they can't lower it for you. Even the most advanced AI-designed drugs still take years to reach patients. This isn't a shortcut to immortality. It's a trade. You trade comfort for clarity, uncertainty for early warnings, plausible deniability for responsibility. And that trade isn't for everyone. If you're anxious, data-obsessive, or looking for certainty, this can make things worse, not better. If you're curious, disciplined, and willing to sit with uncomfortable information, it can change how you live. But here's the line that matters most. AI health works best as a second brain, not a replacement conscience. The danger isn't that machines will control our bodies. It's that we'll outsource judgment, context, and wisdom to dashboards that were never designed to carry them. Used carefully, AI gives you a time advantage. It lets you see risk while it's still optional. Used blindly, it turns life into a never-ending optimization problem, where normal always feels like failure. So should you become AI engineered? Maybe, but only if you understand what you're really signing up for. Not perfection, not certainty, not control, just earlier information, and the burden of deciding what to do with it. Because in the end, no algorithm takes the responsibility. You do,